Hey, everybody. We will be wrapping everything up today, finish up this chapter, um, and then we will review on Monday for the test that will be on Tuesday. We have currently, as I record this, on Thursday, we have started working on the test and putting things together. And I can definitely say that a lot of the questions look pretty much like the problems that you've been doing. Here's an equation, graph it, state the amplitude, period, phase shift, vertical shift, all that good stuff. And then there's a few questions that are from earlier in the chapter, back before we were doing all this graphing stuff. And well, that'll be the goal on Monday, is to make sure that you all know what to expect from this test. But today, all we are doing is nothing really new, just doing everything all at the same time. And so we're going to be dealing with equations that look like this one, where we have basically four different things happening to it. I've got a coefficient in the front, got something multiplied by x. Inside the cosine function, we've got either addition or subtraction, and then outside the cosine function, also addition or subtraction. So we'll just go through, we will state what all of these things are. I'll show you how I graph these, and then we'll see how it all comes together. Amplitude, of course, is the absolute value of the coefficient in front of that. So that is 5. The period is either 2 pi or 360 divided by this k value, since my phase shift is in radians and it's not, there's no degree symbol up here. We'll find the period by doing 2 pi divided by 0.5. Well, and golly, dividing by 0.5, that's the same as dividing by a half, which is the same as multiplying by 2. So this is really 2 pi times 2, which is 4 pi. Phase shift is the one that I'm the most concerned about, because I'm worried that a lot of people are going to say pi over 4, and it's not pi over 4. Remember, we need to write this in factored form in order to see what the phase shift is. So I'm going to factor out that 0.5, and so we'll have x minus something. And so the question is, 0.5 times what would give us pi over 4? So we can think of it either by answering that question. If your number sense is good enough that you just know what that is, then that's great. Otherwise, we can think of it as going from the unfactored to the factored form. Factoring out the 0.5 is like dividing by that 0.5, which again is like multiplying by 2. So we'll end up with pi over 4 times 2, which is pi over 2. And then always, when you get done factoring, if you're doubting yourself, think, if we distributed this, would we end up back where we started? 0.5x, clearly. And then 0.5 times pi over 2, 1/2 of pi over 2 is pi over 4. So I feel pretty good about that, which means my phase shift is pi over 2. And I've been trying to be very careful about this. This is a perfectly good answer if you want to say to the right by pi over 2. If you want to put a plus sign, any one of those is going to be okay. But do not say negative, because that's wrong. We're going to the right. We've got a positive phase shift. And then finally, the vertical shift, same thing. If you want to just say 7, that's okay. If you want to say up 7, that's okay. Or if you want to say plus 7, that gets the job done. So those are our 4 facts. Something I didn't have to worry about yesterday, or yeah, I guess it was yesterday that we were taking a look at this, is that because we're going to the right by pi over 2, because the starting point is moving to the right, I am going to put my vertical axis way over here on the left side. My period determines how big the steps I will be taking. And so a period of 4 pi means 1, 2, 3, 4 intervals later. That's 4 pi. That's kind of convenient that 4 intervals is 4 pi. So each one of these intervals is pi, pi, 2 pi, 3 pi, 4 pi, 5 pi. And then for our vertical scale, I use the combination of the amplitude and the vertical shift. The vertical shift is where I start. The midline has been moved up by 7, so my midline is at 7, and then the amplitude of 5 means we'll go up 5 from 7 to get to 12. We go down 5 from 7 to get to 2. All right, so we know it's going to be a sine curve, excuse me, a cosine curve that looks like this. It's a negative cosine curve, but I also have to keep track of this. I'm moving to the right by pi over 2. So that point that would have been, let's see, a negative cosine curve means I would have started off down here at the bottom, but I'm going to move over to the right by pi over 2. Now, we don't have pi over 2 marked on a graph, but because I've got pi here, I know that pi over 2 is going to be exactly half of that. So there's my starting point back here at pi over 2. The one where it would have crossed here at pi, going from the lowest point to the middle, is also going to be moved over by pi over 2. The point where it was at the, or would have been at the top, has been moved over by that same pi over 2. And all of these points are moved over by that same pi over 2. I can even put the 1 over here on the end. And then you know by now that I like to put those points that are all closer to the place where it crosses the midline. I guess I can't really see one over there. And then finally, we play connect the dots with those points to get a graph that looks like that. The low point, the starting point that would have been at the bottom of the cosine curve, has been shifted over by pi over 2. It'd probably be a good idea for me to mark on my graph that that pi over 2 is the place where this graph starts. And then all the other points have been shifted over by that same amount. We got exactly the same shape, just shifted and stretched and moved all over the place. So there we go. That's what we do. I'll go through a couple other examples. If you feel pretty solid about this, you might want to skip ahead to the last few minutes of this one. But if you would like to see a few more examples, here we go with a few more examples. Amplitude is the absolute value of the coefficient in front. The period is 2 pi divided by this number. 2 pi divided by 2 is simply pi. Phase shift, I don't know, I can't tell it until I factor it, so I'll write it out in factored form. 2 times x plus something. Let's see, 2 times what would be pi over 6? Also, we could think of it as going from the unfactored to the factored means we're dividing 2 out. So pi over 6 divided by 2 gives me pi over 12. I'm skeptical of myself. Is that really right? Well, if I multiply this out, 2 times pi over 12 would be 2 pi over 12, which reduces to pi over 6. Yeah, it looks pretty good. Looks like my phase shift is either negative pi over 12, or if you would like to say to the left by pi over 12, that would be okay also. And then finally, a vertical shift of 10. Up 10, positive 10, but the plus 10 tacked onto the end is going to move the graph up 10 units, which means my midline is now at 10. My amplitude goes up 5 from that and down 5. 10 minus 5 brings me down to the low point of 5. I've got the period of pi. Ooh, I don't have a starting point. Let's see, since I'm moving to the left by pi over 12, I'm moving to the left by an amount that's fairly small relative to my period. I'm going to put my axis right about there. That way, when I mark off my intervals, I can actually go backwards on this one. Something about like that. 4 of those intervals, 1, 2, 3, 4. That's what pi looks like. Half of pi is pi over 2. Half of pi over 2 is pi over 4. So it looks like my intervals, I'm counting off by pi over 4. I've got negative pi over 4 back here. Pi over 4, 2 pi over 4, 3 pi over 4. And then, of course, 4 pi over 4 is just pi. So I've got a graph that looks like that. And now I can start to figure out what this graph is going to look like. I have a positive sine curve, so that normally would have been crossing the midline at the origin, but it's moved to the left by pi over 12. Well, let's see, pi over 4 is too far. And actually, given the way that I've got my graph laid out, pi over 12 will be 1/3 of pi over 4. So right there, move to the left. I'll put a negative pi over 12 on there to represent my starting point. And so all of my points are going to be moved to the left by pi over 12 from the significant places. Pi over 4 is where it would have been up at the top, so moved over by pi over 12. Pi over 2, it would be back at the middle, moved over to the left by pi over 12. 3 pi over 4 would have been at the bottom, move to the left by pi over 12, and then move to the left from pi. And I might as well do the same thing over here and mark that spot. And then, oh dear, those points don't make sense. It was coming up, then the midline that would be down at the bottom over here. So my significant points. When I refer to the 5 significant points, I'm just talking about the middle top, middle bottom, and etc. Personally, I like to have these little points here so that I make a smoother looking graph. When I play connect the dots, I know where things start to level out and give me a graph that looks like that. This is a sine curve that's been shifted to the left by pi over 12, but really could be interpreted as a cosine curve that's been shifted to the right by, I suppose, if this is pi over 12, 2 pi over 12, this would be by pi over 6. So cosine of a graph that's been shifted over pi over 6 would look exactly the same. And then one more of these before we move on and do another problem that's a little bit similar. Amplitude is the absolute value of that number that is in the front, the coefficient on the whole expression. Period is, I might have to write this one out. Period is 2 pi divided by the k value. So 2 pi divided by 2/5 or multiplied by 5/2, which will give me, oh, look at that. I'm doing this problem in degrees, and here I used radians. Sorry about that. I should have been multiplying 360. 360 divided by 2/5 or 360 times 5/2. Let's see, half of 360 is 180. 180 times 5. 18 times 5 is 90, so this will give us 900 degrees for the period of this graph. And then for the phase shift, for the third time today, let's factor out that 2/5. See what's left over, x plus something. Similar to how I did the previous problems, I could either answer the question 2/5 times what is 20? And again, some of you may have number sense such that you can just think about that and know the answer. For the rest of us, I'll think of this as dividing by 2/5. 20 divided by 2/5 is the same thing as 20 times 5/2. So either 100 divided by 2 or 10 times 5 to get 50 for our phase shift. And then finally the vertical shift, either negative 100 or down 100, either one of those will be just fine. So as I make my scale, as I draw this thing out, my midline is going to be at negative 100 because the graph has been moved down 100. Up 25, the amplitude is 25, so up 25 from that is negative 75. Down, negative 100 minus 25 is negative 125. And then for my horizontal scale, let's see, I've got a period of 900 degrees and it's moved to the left by 50. So similar to the previous one, the amount that it's moved over is not too significant, which means I'll make my scale in such a way that 1, 2, 3, 4 intervals, that is 900 degrees. Half of 900 is 450. Half of 450 is 225. So each one of my blue marked intervals here is 225 degrees. That means negative 225 is back here. And then 450 plus 225 would bring us to 675 degrees. So there is my marked scale looking something like that. And then finally, after all that work, we have graphed 0 points. And so now we've done all the work, we've laid the groundwork. I've got a nice scale here so that when I make the graph, it'll look pretty. Let's see, we're moving to the left by 50 degrees. I have a positive cosine graph. So the top would have been the starting point, but it's been moved to the left by 50 degrees. And I don't have 50 degrees marked on here very clearly. This is 225, which means each of these little sections is only 75 degrees, which means 50 is about, well, it's exactly 2/3 of one of those sections. So there we go. My significant point that would have been at the top because it's a positive cosine curve has been shifted to the left by 50 degrees. And the same goes for all the rest of the points. The point where it would have crossed at 225 is moved to the left by 50 degrees. Here it would have been at the bottom, moved to the left by 50 degrees, back to the midline, moved to the left by 50 degrees, and up at the top, moved to the left by 50 degrees. I can do the same thing over here. And then finally, my usual dots to mark a little fine tuning of my graph. And plane connect the dots will result in a graph that looks about like that. I'm not going to be looking for perfection on Tuesday, but I'm also going to be looking for something better than zigzags. Have some curve to it. Take pride in making it look fairly nice. Not necessarily perfect. I'm not going to claim that my graphs are perfect, but I think they look pretty good. And then finally, just one other set of questions that I wanted to take a look at that we really haven't had a chance to take a look at. Suppose I give you a graph, or maybe I tell you I want you to give me an equation for a graph that has these properties, an amplitude of this, a period of this, etc. And so for a graph that looks like this one, this goes way back to when we were first starting this chapter. I'm going from -1 all the way up to +4, so that's a difference of 5, which means my amplitude is 2.5, 2.5, or 5 halves. The period is a little bit tricky to figure out on this one because it doesn't start exactly at 0. Doesn't look like it's a nice numerical value that tells me how far it's going over. But I do notice that the place where it would cross the midline right here at exactly 1.5 looks like that's a point that is right where it's crossing the midline. I don't see any maximum values that are right on a nice number. This one's close to 2, this one's close to 0. This looks like it's really nailing it right there. And so if I try to figure out how far it goes before it goes through one full cycle, looks like we're at about 1 point something, something not too big. Maybe we'll call that about 1.3. And notice that I'm not being super careful about that. I'm actually looking at it, I'm scanning to see if there's any other significant points that we could use that might give me a better idea of what the period is. But I think I'm going to go with 1.3. I don't see anything. And maybe you're looking at that thinking it looks more like 1.25 or 1.2, and that's perfectly fine. I'm going to go with 1.3 for me figuring out the equation. For my phase shift, if I say that this is a sine curve, well, then my phase shift, that starting point where it's crossing the midline and increasing, looks like it's been moved over by exactly 1. If you say this is a cosine curve, you could say that it's moved over by about 0.1, or maybe 1.4, or maybe 2.6 or something like that. This is just one possible answer, but if I think of this as a sine curve moved over by 1, that's going to work out just fine. And then my vertical shift, that midline is moved up to 1.5. And so my equation, given my my properties here, my equation is going to be y equals the amplitude, 2.5. I'm treating this as a sine curve. This isn't the only way to do it, but I'm going to treat it as a sine curve. The period is 1.3, which means the k value that's going to go in here is 2 pi divided by 1.3. And I'm not a big fan of decimals inside of fractions, but if I want a numerical value, I could plug that in there. X minus my phase shift, x minus 1 is going to move it to the right by 1 spot. And then finally, vertical shift of 1.5. I tack on the 1.5, and that will move it up. I would suggest that you practice a little bit with this. Just make a graph, or maybe have a friend make a graph with all different numbers and have them send it to you and have you try to come up with something, and then you can try to figure out what an equation is that matches it. And maybe you come up with exactly the same equation that your friend had, or maybe you come up with something that's different that looks exactly the same. And either one of those would be okay. We'll just do one more of these and then I'll be done for today. For this one, I'm looking at my amplitude. The amplitude is going, let's see, from -8 up to +2. That's a difference of 6. So I've got an amplitude of 3. The period of this graph, let's see, the place where it's crossing the axis over here isn't very easy to tell. I'm going to look at my maximum points. This one looks like it's just a little tiny bit to the right of 150, and this one's a little tiny bit to the right of -60. And so between -60 and -150, that's a total distance of 90. So I'm going to say this is a period of 90, maybe even 90 degrees, but I'll just go with 90. The phase shift, well, it depends how I want to treat this one. If I want to treat it as a sine curve, I would find my midline, that's right here at -5, and I could maybe say that it's a negative sine curve moved to the left by about 40. Or maybe it's a positive sine curve that's been moved to the left by maybe about 80 degrees. Or maybe it's a negative sine moved to the left by -125. Or maybe it's a positive sine moved to the left by -170. I'm going to stick with, well, let's see, we did a cosine last time, or a sine last time. Let's do a cosine for this one. And if I want to treat this as a cosine, I'm looking at this point as my starting point. And gosh, it's so close to -60. I think I'm going to say that it's a phase shift to -59. This is an inexact science, and that's okay. If you think that looks like -60, if you think that looks like -58, if you think it looks like -59.5 for some reason, go with that. And then my vertical shift, let's see, halfway between -2 and -8, we got -5. So the midline's at -5. The graph has been moved down by 5. I'll put -5 for the vertical shift. And then let's write the equation down. I have a positive cosine graph, so 3 times cosine of. My period is 90 degrees, so let's do this problem in degrees. So 360 divided by 90, 360 divided by 90 would be 4. I'm going to put this in factored form. 4 times x minus my phase shift. Whoops, that's moving to the left, so we'll call it x plus 59, x minus -59, or x plus 59. And I suppose technically I need a degree symbol there. And then finally minus 5. I'll move that graph down. And if you graph this on your graphing calculator in degree mode and change your window to fit what I've got up here, it should look pretty similar to what I've got. Okay. Keep working on the assignment, keep turning those in, keep asking the questions that many of you have been asking. If you have any other questions or concerns, get in touch with me. Otherwise, have a wonderful weekend. We'll see what the weather's going to be like, but we will get you guys ready on Monday. I may publish the review assignment a little bit earlier than Monday to give you guys a chance to look at that one, if I think of doing that. And feel free. I know some of you are good at letting me know when I forget to post something. If you want the review assignment, you want me to post it, just shoot me an email, and I can definitely get that up for you to work on. All right. Have a wonderful day. Miss you guys, and I'll see you later. Bye-bye.